Module 6.2, More Derivatives of Trig Functions. Objective 1, find the derivatives of more trig functions. Objective 2, use derivatives to solve real-world applications. Once again, here are the derivatives of the trig functions. Example 1, let's find the second derivative if f of x is equal to 6 secant x. Okay, so our first derivative of x is going to be equal to 6 times, and the derivative of secant x is going to be secant tangent. Okay, now to find the second derivative, let's look at what we have here. We have a product, so we're going to have to use the product rule. And we already know that secant, the derivative of secant, gives us secant tangent. And we know that the derivative of tangent gives us secant squared. So let's go ahead and use our product rule now. So first we have 6 times, okay, u would be secant x, times the derivative of tangent would be secant squared x, plus the derivative of the first one, derivative of secant would be secant x tangent x, times the second one, which is tangent x. So that would give us 6 times secant cubed plus secant x tangent squared. And I could factor out a secant, so that would give me 6 secant x times secant squared x plus tangent squared x. And I'm done. Example 2. Find the second derivative if f of x is equal to 8 cosecant x. So in order for us to find the first derivative, we need to know what the derivative of cosecant x is. And the derivative of cosecant is negative cosecant cotangent. So our first derivative is going to be equal to negative 8 cosecant x cotangent x. Now, in order to find the second derivative, we're going to need a couple things. One, we've already got the derivative of cosecant, but we're going to need the derivative of cotangent. And the derivative of cotangent x is negative cosecant squared of x. So, the second thing that we're going to need is the fact that these two are multiplied together. We're going to have to use the product rule. Okay, so let's begin our derivative. We've got negative 8 on the outside. We're going to, first one is u. We're going to use cosecant x times the derivative of the second one. Well, the derivative of cotangent is negative cosecant squared x plus the derivative of the first one, which is going to be negative cosecant x cotangent x, times the second one, which is cotangent x. Okay, that'll give us negative 8 times negative cosecant cubed of x minus, and we're going to end up with cosecant x cotangent squared of x. And we'll be able to factor out a negative and a cosecant. So that's going to give us positive 8 cosecant x times cosecant squared x plus cotangent squared x. Example 3, find the second derivative if f of x is equal to 8 tangent x. So our first derivative, we're going to need to find what the derivative of tangent x is. And the derivative of tangent x is secant squared of x. So this is just going to simply give us 8 times secant squared of x. And we can rewrite this for our second derivative, let's rewrite this as 8 secant x quantity squared. That way I can use my chain rule. And the good thing about this is we have a derivative for secant x, which is secant tangent x. So this is going to be our second derivative of x is going to be equal to 16 times secant x to the first power, because we subtract 1, times the derivative of secant x, which is secant x tangent x. And so that'll give us, for our second derivative, that'll give us 16 secant squared x times tangent. Objective 2. Use derivatives to solve real-world problems. Example 1. A weight hanging from a spring bobs up and down with a position function s of t is equal to 3 sine t, where s is in meters and t is in seconds. Find the velocity and acceleration at time t. Well, our velocity is nothing more than the first derivative. So the first derivative of 3 sine t would be equal to 3 cosine t. And we have taken care of the first derivative. And this is, by the way, velocity, or the change in distance. Okay? Our second derivative of this, which is going to give us acceleration, we're going to take the derivative of cosine t, which will be 3 times negative sine t. So that would be equal to negative 3 sine t. And this is our second derivative, which is also called acceleration. In our next example, a body is moving in simple harmonic motion with position function s of t is equal to 4 cosine t. Find the jerk at time t. Well, the jerk is actually going to be the third derivative. And so let's start off with the first derivative of t, which is going to be equal to 4 times, and the derivative of cosine is negative sine t. So this will give us negative 4 sine of t. Our second derivative, which was the acceleration, that would be equal to negative 4, and then the derivative of sine t would be cosine of t. And our third derivative, which is called jerk, is going to be equal to negative 4 times the derivative of cosine t, which is negative sine of t. And so this would be equal to 4 sine of t, and that is our jerk.